All right. So we're going to talk about number 6 and number 7. Like I said, it's Thursday. We don't have a whole lot of time today, so we're not going to spend a whole lot of time on this worksheet. We got to get through our lesson and talk about our worksheet 37. So number 6, let's go ahead and split down the equal sign just like so. Now, what do we notice that's a little bit interesting about the left side of this equation that we're not really used to seeing on this type of problem? They're like terms, right? So instead of having a variable and a constant equals a variable and a constant, here we have a variable plus a variable equals a constant minus a variable. So if it helps when you're going through identifying your terms, if you want to put V's and C's above them just to keep it nice and consistent, please go ahead and do that. We're going to combine these like terms on the left-hand side. 2b plus 4b, we got the same variable, so we know that they're like terms. We're going to circle up the 2 plus 4 portion and bring that out in front. Don't worry about red pens for today, just correct with a pencil if you have it. What's our new coefficient on the left? 6 with the b equals 56 minus b. All right, we've combined our like terms on the left, but now we've got to bring all of our variable terms over to the left as well. So what do we want to do? We're going to add what to both sides? We're going to add b to both sides. This variable term over here on the right, we've got to figure out a way to get it over with its friend over here on the left. Well, if it's a minus b, we do the inverse operation, which is plus b, so that we can cancel those out on the right. And now we're just left with 7b equals 56. Because when we add b to each side, remember there's an invisible 1 in front of that b that we have to include when we're adding. So it's 6b plus 1b, giving us 7b. 7b is equal to 56. What are we going to do to both sides now? Divide by 7, that's right. Those 7's cancel. B is equal to what, everybody? 8, right? 56 over 7. Just going to give us 8. Questions on number 6? Okay. Number 7, there's not a whole lot going on, but usually those are the trickiest types of problems, right? When it looks a little bit weird, there's not a lot going on. But this is pretty straightforward. If this would ever focus. There we go. So we're going to split our equation. Do we have any like terms on the same side that we need to combine first? No, we've got a constant term with a variable term, and on the right-hand side we've got a variable term. So, like I mentioned kind of a little bit in the warm-up, there's sometimes when you'll notice, hopefully notice, that bringing your variable term over to the right instead of bringing it over to the left is a lot easier for us. This is one of those instances here. Because what happens if we were to subtract 3x from both sides? Blake, what would happen? You were right. What you started saying was right.
There wouldn't be any numbers on the right side.
Yeah, we wouldn't have anything on the right. If we subtracted 3x from 3x, we just have 0 over here on the right. So to avoid doing that, let's just see what happens if we add x to both sides instead. We're able to do that. There's no rule saying we can't bring our variables over to the right. What's negative x plus x going to be? 0, right? They cancel out, leaving us with 4 equals what? 4x, right? 3x plus 1x gives us 4x. Now this is a nice simple one-step equation that we could solve pretty easily. What are we going to do to both sides now? Divide by 4, right? What's 4 over 4 equal to? 1. So here's what would happen if we did it the other way. Let's just, for the sake of argument here, let's see what would happen if we subtracted 3x over to the left instead. So if we do minus 3x, what would minus x minus 3x be? Negative 4x equals 0. Now what can we do? Well, we brought our variable term over to the left. Let's bring our constant term over to the right. 0 and 4 are like terms, right? They're both constants. There's no variable attached to them, so we can combine them. What would 0 minus 4 be? Negative 4. And now we can see that we're going to get the same answer either way, right? Because we divide by negative 4 this time. And all these negative 4's cancel out to still just be 1. So either way, you're going to get the same answer, but one of them is a little bit more work, we can clearly see, right? So the more exposure we get to these types of problems, the more comfortable you're going to be deciding which move is going to be easier. This is one of those instances where we see, hey, there's no constant on the right. There's just a variable. So let's just solidify that. Let's keep our variable on the right, bring that minus x over, and then solve from there. Like 2 less steps, but you get the same answer if you do everything correctly. Questions about 7? That was a really good one for us to go over. All right. We got to move on, folks. So go ahead and give this